Good evening, everyone. Thank you for joining us. For those of you who don't already know me, I'm Lynn Cooley, the Dean of the Graduate School of Arts and Sciences. I'm very pleased to welcome you to our first presentation in a series of conversations with Yale Graduate School alumni, sponsored by the Graduate School and its Alumni Board. This series, called Perspectives, is meant to bridge our alumni and student communities, sharing alumni experiences and insights as both models for success and to open opportunities for alumni and students to connect. I have ambitious goals for transforming and evolving Yale's approach to doctoral education, as well as plans to strengthen and build our alumni community, to connect our faculty, administrators, and students more frequently, and to help ignite these connections in support of our students. I look forward to using what we learn from this series to think about how we can continue to improve graduate student experiences for all students. So today we will be joined by Charles D. Brown II, Ph.D. alumnus from the Department of Physics, as well as Jia Chen, who is our Vice Chair of the Graduate School Alumni Board, and Matthew Tanico, Assistant Dean for Graduate Student Life in the Graduate School. We hope that you will enjoy this conversation about Charles's scholarship and the lessons he has learned from his days as a graduate student at Yale. I'm really glad to have graduate students, alumni, and faculty and old friends of Charles tuning in from around the world, and I hope you will enjoy the conversation.
Hi, everyone. Good evening. My name is Matthew Tanico, and as Lynn mentioned, I'm the Assistant Dean for Graduate Student Life here at Yale. Before we get started, I want to share a few housekeeping items with you. We'll be recording this webinar, and we'll share the recording after the conversation. We're also offering closed captioning, and you can control that via the button on the bottom of your screen. In the second half of the session, we'll be saving some time for questions and answers. Many graduate students and alumni have submitted questions in advance, but we also hope that you'll enter additional questions using the Q&A feature at the bottom of your screen. I'll be moderating this discussion with my fellow alum, Jia Chen, Vice Chair of the Graduate School Alumni Association Board, who is a Yale GSAS alumna from the Department of Physics. I'll rely on her for the technical background as a humanist. Now, I'm delighted to introduce Charles D. Brown II. Charles received his PhD in physics from Yale in 2019 and is currently a National Academies of Science, Engineering, and Medicine Ford Foundation postdoctoral fellow in the ultra-cold atomic physics group in the Department of Physics at the University of California, Berkeley, as well as co-founder and co-lead organizer of #Black in Physics Week, a week dedicated to celebrating the historical contributions of Black physicists. Welcome, Jia and Charles.
Thank you very much, Matthew. Thank you, Dean Lynn Cooley. Thank you for this opportunity. So I am the Vice Chair of the Graduate School Alumni Board, and I'm delighted to have this opportunity to pose a first question to our guest, Charles. Charles, I noticed actually last week you gave a talk at our physics club about a complex topic of lattice-trapped quantum gas. So very interesting. I wonder whether the talk was virtual, in person, or it's a hybridization of giving a virtual conference on campus. So, but we'd like to ask you about your research in grad school and your work in current role and how that work evolved.
I'm happy to talk about that. But first, thank you very much for having me here. I'm very excited to have this opportunity to talk with you all about a series of very important topics to me. But to the research. So as a PhD student, I worked in a field called optomechanics. Opto referring to light, mechanics referring to some sort of oscillatory motion of an object in the field where the light, or in the area where the light exists. So it turns out that if you can confine some amount of light to some geometry and you can oscillate some object within it, you can produce an interaction between the light and the mechanical object that's oscillating in a way where they sort of mutually affect each other's behavior. It turns out that you can use that system to do, potentially, to do some very technologically interesting things. For example, do networking between different kinds of devices. Perhaps quantum computing devices, when they exist in the future and you need to sort of have them talk to each other. An optomechanical platform is an interesting one to do that sort of work. It also turns out that if you want to do something like test the limits of quantum mechanics, if you want to see sort of how big a mechanical object can be, a massive object can be and still exhibit quantum behavior, sort of, almost wacky physics behavior that you don't see in your normal life or in normal length scales, an optomechanical system is an interesting one to use to try to, really understand what is the limits of the size of a system in which you can see quantum mechanics. And so in my PhD, I did things like have light interact with density fluctuations in a really special kind of liquid. That was sort of half of my time in grad school. The other half of my time in grad school was building a new, very interesting system, which involved levitating a drop of superfluid liquid helium. This is a very interesting state of matter that flows with zero viscosity. You can use very powerful magnetic fields to levitate that liquid, and you can shine lasers on it, where some of the light will get trapped inside of the drop, and that light will interact with the drop's vibrations. So now you have a new kind of optomechanical system that's well isolated from its environment, and so well positioned to eventually study some interesting quantum physics phenomena. Now, as a postdoc, I do something quite different, but still quantum mechanics, quantum physics is at the heart of what I study. So to sort of introduce this, it's useful to think about solid materials. A solid, say a crystal, it is a periodic arrangement of ions where electrons hop back and forth between the different positions of the ions. The hopping of those electrons around the material determines a lot of the material's properties. Now you can make a lattice completely out of light. This is what I do now. And you can make atoms really, really cold. You can throw those atoms into that lattice made of light, and those atoms will hop around the lattice. And it turns out that this platform is a nice system to sort of simulate a real solid crystal. But our system is on a larger scale. It's easier to image. Everything is slowed down and more easily measurable with our current technology. And so we can use these sort of quantum simulation experiments to gain insight into the physics, the quantum physics of materials in a way that is difficult for people that study this sort of physics in solid materials. And it's all sort of a platform to start learning about how when you have a large system with many interacting particles, where quantum mechanics is important, sort of how does the system behave? There's lots of open and very interesting questions there. And so now I'm geared towards trying to address those sorts of questions.
Very fascinating, Charles. Wow. Matthew, what do you think?
Yeah, no, thank you. Sorry, I was reading as the typical Zoom problems that we have. No, that was amazing, Charles. Can you talk a little bit about the sort of move that you've made in your own career? And I want to talk a little bit about the hashtag Black in Physics week that you started. Some of our fellow Alumni Association board members actually came across your article, which is part of the reason why we wanted to bring you to be in conversation with us this evening. And you've written in your somewhat scholarly work, I would still call it that, about your own experiences with bias and anti-Blackness within the academy. And so as a result of that, those experiences, you started hashtag Black in Physics. Can you tell us a little bit more about the initiative, but also about some of those experiences that you felt both as a graduate student and in your current role as a postdoc, but more generally as a physicist?
Yeah, absolutely. So I actually have a lot to say here, as you might imagine. But I think I can sort of quickly sum up my experiences in the academy with the idea that, as I wrote in the the Physics Today article you're referencing, Disentangling Anti-Blackness from Physics, many of my experiences as a student involved people who had a hard time understanding that I was part of the intellectual community. And so it was often the case that I was sort of thought to not belong in certain spaces, and that made for very difficult interactions. And it was sort of the buildup of this over years that was very difficult. And, you know, this is not a problem unique to Yale. This is a problem that sort of happens when you have a very small number of people that look like me in a space where the people who make up the majority of the institution aren't used to seeing people like me around, or maybe haven't even had many previous experiences interacting with, say, Black people. Well, that was surprising, let alone in an intellectual capacity. So I think that has summed up many of my experiences as a student at Yale, and it has also, you know, played a part in some of my experiences as a postdoc here at Berkeley. So let me address Black in physics. So, you know, I guess the question is sort of, why did it come about? Well, Black in physics was born during a moment of chaos as a way for the community of Black physicists to come together and gain a foothold as the world around us seemed to be on shaky ground. Now, another organization, the National Society of Black Physicists, started an important aspect of this community building work, and it's been doing so for decades. But on our side, we wanted to sort of further build such a community based on modern social media tools that grant a new level of global access and allow for new ways for distant individuals to engage and remain engaged with each other. You know, part of our goal with Black in Physics is to paint a more complete picture of what a physicist looks like. Unfortunately, only about 3% of physics bachelors go to Black physicists, and only 2% of PhDs go to Black physicists. This necessarily means that the number of Black physicists in lab directorship roles, be they in academia or industry, is small. And it was just last year in the entire multi-century history of US higher education that we crossed the threshold of 100 US-born African-American women having attained PhDs in physics or astronomy. And so, you know, even though our numbers are small, Black physicists have played an important role in the history of physics, whether it be their roles as sort of research associates in labs, say students or postdocs or the equivalent, or as principal investigators directing research labs. And it turns out that Yale has an important role in this history, right? The first Black American to receive a PhD in the US was a man by the name of Edward Boucher, and it was awarded in physics by Yale in, I believe, 1876. With its history as a leader in many fields, its great influence, you know, not only in the academic sphere, but also in the larger societal sphere. You know, Yale is given its great resources well positioned to truly lead in attracting and, importantly, retaining diverse talent that'll level the playing field. So yeah, with Black in Physics, we're not only shining a light on the important contributions of these physicists by, for example, leading Wikipedia editing campaigns that produce pages for accomplished scientists who previously either had no page or whose page was only sparsely populated, but we also provide a microphone to amplify the voices of these physicists through our, you know, widely read, highly visible series of publications that appear both in Physics Today and Physics World magazines, which have global reach. You know, at this point, we've reached a point where we've made it difficult to not see all of the many talented Black physicists who are highly qualified to hold principal investigator roles, such as professorships or staff scientist positions at national labs or research team leads in industry. And we've aided in making it quite clear that the talent exists and where to find it. The next step is to truly value Black physicists' contributions and to understand that in order to continue to grow and be better, physics as a discipline must make space, healthy and welcoming space, supportive and respectful space for Black physicists, so that not only can the discipline reap the benefits of our much needed perspective, but also so that Black physicists can reap the socioeconomic benefit of having highly valuable technical knowledge in a highly tech-driven society that constantly faces moral dilemmas that affect many different groups of people, but typically only have one group of people making the decisions, often with an unacceptably low understanding of how people from different groups are affected with those decisions. I know that was sort of a long spiel, but that's my take on Black in Physics. And sort of that is why we are doing what we are doing and why our work is important.
I really appreciate that. And can you speak a little bit to the way in which there's pressure both from within and beyond the academy around this? I'm not 100% sure about your own experiences with this, but I know for graduate students who are currently at Yale, there's a lot of thought into whether or not you stay within the academy and you become a faculty member or to leave the academy. And has that played a role at all, has Black in Physics helped you navigate the sort of career trajectory that you've decided to pursue?
Yeah, so I think Black in Physics has helped me navigate my career trajectory. Before Black in Physics, it was the National Society of Black Physicists. And when I first started graduate school, I had decided to go to graduate school because I said to myself, I want to work as a professional physicist. And typically, in order to do professional physicist work, you would have a PhD. And so I found myself in grad school. Throughout my grad school process, especially given the difficulties, especially given my difficulty with having a lot of messaging that suggested that I didn't belong in physics, I sort of went through this very windy roller coaster of I need to get out of here ASAP. And, I need to be a part of academia and not only do excellent physics, but also like really take part in shepherding the future of the academy. Right? There's a very windy path between those two. And when I first went to the National Society of Black Physicists Conference, which Meg Urey actually sort of made happen, that was my first time seeing so many Black scientists, so many Black physicists. That was my first time meeting any. And that was a completely life-changing experience for me. And so that was something that really sort of put it in my mind and heart that this physics thing is something that I could really do. And I think that my work with Black in Physics has sort of further strengthened that feeling in my mind, right? So now I'm sort of taking a more of a leadership role in the field, right? I certainly benefit from the resources that we provide, but I'm gathering people. And I'm further sort of deepening my anchor to the field. And I'm helping pull up younger people and trying to make sure at least that some of the problems that I dealt with are less effective at pushing people out or maybe even absent. Yeah.
Very interesting. Wow. So I was reading your Physics Today commentary about disentangling the anti-Blackness from physics. And you cited how, you were one of roughly 25 Black men in Yale grad school at the time, 2015. So, but you also, just now you talked about meeting other like-minded people and energized you and gave you confidence and conviction. So I'm curious how you kind of transitioned and got inspired to actually reaching out and to build a community, and what kind of advice you would have for current students who may have similar experiences in grad school, that may be in physics or other science area, and how what advice and how can they also learn to build community and leverage each other?
So yeah, that's an excellent question, incredibly important for students and really for everyone. And it happens to turn out that some of us, in particular ethnic minorities or gender minorities or other underrepresented folks on campus, don't always find themselves in communities in the way that more represented people do sort of automatically. And so I made a point to build community out of necessity because I didn't have it and I didn't initially realize the importance of it. And it really became clear that I needed to be able to talk to other people about my experiences, people that sort of automatically understood my experiences, definitely people who I could talk to that like didn't hold preconceived notions, say of my like intellectual ability, who really could take me for at face value and respect me fully as a human, with an educated one that has lots of useful and important thoughts to contribute. And so my first sort of major go at this at Yale was the formation of the Yale League of Black Scientists. So this was a student group that I formed with two other Yale graduates. One is my wife, Lindsay McMillan Brown, who I believe is in the audience. She got her Ph.D. in chemical engineering a little bit before me. I can't remember when anymore. But then also Brooke Russell, who got her Ph.D. from Yale Physics, and she was the first Black woman to get her Ph.D. from Yale Physics. She was in my cohort. So yeah, we started this group, and it was great because it was a mechanism through which we can apply for funds in the university through the very nice student group system at Yale in order to like create programming that can support Black STEM PhD students. And that could be like sort of professional development, which we did, or also even social events, because a lot of the Black students at Yale were in the humanities and social sciences, and they're on a different part of campus. And so as a grad student, it's easy to be isolated. And if you're a Black STEM PhD student, I mean, the combination of being physically far away from other Black students and there being few Black STEM PhD students mean it's very, very easy for you to be alone. And so Yale League of Black Scientists was a mechanism to produce programming that sort of supported our professional development as PhD students, as Black ones, that helped us socialize with each other, and that kept us engaged in the local community. So another thing we did was we got very engaged with the Pathways to Science office, which is sort of attached to the main outreach arm of Yale. And we were everywhere around the city. We were in local schools, and we were interacting with kids from local schools here, or not here, I'm not at Yale, but on the Yale campus. And that was actually a really important part of providing anchors for us. That sort of work made it clear that our presence there was important and that we were making important changes. And so this is sort of long-winded, but I can say that community is super important and everyone needs community. Some people sort of get it for free, and it tends to be the case that underrepresented people have to work for it or even build it because in many cases, it doesn't already exist. And so one good way for students to find community is to, well, go around and look for the resources that exist. Yale has many excellent resources, especially for students. And if you find something that you need doesn't exist, build it. And I found that there were many people, both in the physics department or higher up, including Dean Cooley, who supported the Yale League of Black Scientists and tried to make sure that we had the resources we needed to support ourselves. This also means going and talking to people, leaning on people, being authentic and real about your experiences. I mean, being a Yale students are strong students who have histories of being strong students and sometimes go to Yale and have a hard time and can have a hard time being honest about having a hard time. But I think in order to make the sort of connections you need and build a community, you need to really thrive as a human. You need to be open with other people, reach out, and let it be known that it's okay to sort of struggle with things. And so that may involve going and having, real, maybe even heartfelt conversations with your peers or reaching out to faculty. That's something that I did a lot. I was fortunate to have a fantastic PhD advisor who I spoke to about everything. I was lucky to have that. But there are other people on the Yale physics faculty that were incredible mentors for me that I reached out to about my issues, and they supported me in the way that they could. And so that was another way of building community. And so my message to students would be, identify the faculty that care about you. There will be several, and they are well-resourced, influential and powerful people that can make very serious changes in your life for the better.
Wow. Okay, thank you for sharing. I like, what you said, being authentic, be authentic about our hardship sometimes, be willing to open up and also to seek out. And I think like I was also in a way a minority when I was there, and I mean, I didn't know better. So I was speaking out and seeking out help. So it's great that, you've had a great support system. I mean, in a way, you build it yourself. You reach out to your advisor, to other faculties, and to fellow students in even in the humanities. That's very
Yeah,
impressive.
absolutely. And actually, if I could add, I'll say that our friends, so, I'm speaking as a physicist, I would say our friends on the humanities and social sciences side have been incredibly important to me in a way that I couldn't have known would be true before I got to Yale. And I had the privilege of interacting with so many of them. They gave me so many tools to sort of contextualize my experience as a human. They gave me language to talk about important issues. And so, I would have been worse off if I did not have the fortune of interacting with so many people on the humanities and social science side. Just want to add that. Very important, very important.
Thank you.
Really appreciate your candidness about all of this, Charles, and that vulnerability that I think a lot of students will empathize with and sympathize with. And also, I just really commend you on the ways in which you were able during your time at Yale to reach out to so many communities. You were talking a bit about community, but the ways in which you created you reached out to the scholarly communities, the National Society of Black Physicists and others, but also your department, beyond your department, the graduate school community, but even the New Haven community, talking about the Pathways program, which is so wonderful. And I think you're a model of what we hope graduate students will do, and to re-emphasize that the Dean's Office is here to support students in that way. It's so wonderful to hear stories of students really taking advantage of all there is to get out of this place. And you've referred a couple of times to mentorship, and you even mentioned Meg Uri, who I believe is on the call tonight. And I wanted to ask you a little bit specifically, because on the one hand, there is the building of communities, but also I want to ask you about how you found mentors. And we talked a lot about sort of peers and finding your peers, but finding good faculty members, both as a graduate student and now as a postdoc, as you grow in your own career, how have your thoughts about mentorship evolved and how you see yourself as a mentor? And can you speak a little bit to that?
Yeah, so let me first say that unequivocally, mentorship is incredibly important, and it's important for everyone. And again, it turns out to be the case that while mentorship is important for everyone, it's often that underrepresented minorities don't find themselves in the sort of important mentorship relationship that they need to thrive in a way that more represented groups do. Some of which sort of get it for free, even. So how did I end up, having strong mentors? It was born out of me being authentic and me asking for help, me describing the issues that I was having, and seeking people that sort of could understand what I was trying to describe, didn't necessarily have preconceived notions of my background, my ability, wouldn't necessarily be like, oh, you're just being sensitive. That's not real. Or, that really listened to me. And I think I was fortunate to get in a number of ways. I mentioned that I had a great Ph.D. advisor, and that was really important to my experience. And I think not all students are as fortunate to have such a great advisor. My Ph.D. advisor was not only a fantastic scientist, but he's someone that obviously very much cares about the people that work in his group. And he was very open to learning a lot about my experience throughout my time. And he made it clear that I could be open with him about the difficulties that I was having. And I did this with other faculty. I already mentioned Meg. I was a teaching fellow for Meg for definitely one semester. And we were having a conversation about women in physics. And I think I said something like, okay, well, if you think this about women in physics, what do you think about Black people in physics? And that turned into a 5-hour conversation in her office, where I pretty much just unloaded all of my difficulties on Meg. And she listened and she gave me lots of resources. She made it happen that I went to the National Society of Black Physicists conference and had this life-changing experience. So for me, gaining mentors has, again, been being authentic about the difficulties that I'm having and asking for help, and not necessarily being stuck on having mentors that look exactly like me. I will be the first one to tell you that role models are incredibly important. And so for that reason, Yale should continue its work even more aggressively to say diversify the faculty. So I think it's important for students like people who share my identity, for example, to see a role model that looks like them. However, in the current landscape, students and really everybody at all levels, they need to be able to identify what they need and find mentors that speak to different aspects of their personality or that can provide different resources. And so, what was the case for me in my time at Yale and even now is me finding multiple mentors that speak to different parts of my identity as a physicist and as a human. And together, I sort of have all of my needs fulfilled by this sort of network of mentorship. And I think that that's a really important lesson for students. Go and find people that care about you, that can speak to different parts of your identity, and that will serve you incredibly well. And again, I keep saying students, but it's not just students. Like, you still need mentorship if you're a postdoc. You still need mentorship if you're a junior faculty member. Even if you're a full professor, I mean, you're going to be engaging in things where there is some more experienced person that's not necessarily older than you, but that can help guide you through a process where guiding is very necessary. This is sort of always the case. So I think that message is important really for everybody.
I appreciate that.
Yeah.
I often tell graduate students, in fact, that Yale is just made up of people, and that's how you sort of have to navigate this place. You can't just talk about Yale as an entity on its own, but it's actually made up of individuals. And it sounds like you've met many of them who have helped you in your career, and now you're helping as an alum. So we appreciate that.
Yeah, absolutely. So I knew that was a multi-part question. Did I answer all the parts of that question?
Yeah, I think we hit on some topics, and there'll be more. There are some questions coming through on the chat. I'll also put a plug in now to please continue submitting questions to the Q&A. But I'll pass it over to Ja for the next one.
Thank you, Matthew. So yeah, I was wondering, now Charles, you're an alum now, so maybe you're already offering some help and advice to fellow students in physics today. The other question is, you kind of touched upon at the end of your last topic. I'm combining this with, a question from Stephanie, right? I mean, it takes a lot of initiative to build that network, the infrastructure, the support system. Now, what kind of advice you have from sort of an institution level, an educational institution level, what changes we need to put in place, what kind of developments, like what additional infrastructure we should help to facilitate to make this easier for all students, to be inclusive, for them easier to find the support they need.
Yeah, so I think that so to me, and really important part of this is diversifying at different levels. So one thing that I think is really great that the physics department has achieved recently is really increasing the amount of women in the department. If I remember this, I heard that the last incoming graduate school class was maybe majority women, maybe 55% women or something. And I think that's really special for a department that for a long time hadn't had very many women. And that's important because, it's more so the case that new women who are students can go in and see themselves represented. They have more people that can speak to their identity, that sort of understand some of the struggles that they go through. There's already sort of a foundation for community. And that same kind of thing is important, for example, for Black people, say me, for Black men, right? And so I think at multiple levels, if we could have, so let me just use this as an example because I think about physics. And let me use my identity as an example. What I'm saying is we need to have more Black graduates in the physics department. And so that means we need to improve our recruitment efforts. We need to have more Black graduate students in the physics department. And so we need to improve our recruitment efforts. We need to have Black postdocs in the physics department. And so we need to improve our recruitment efforts. And the same is true for faculty. And I think like if you can pull several individuals that represent these different identities into the department, again, there's already a foundation for community, and it will start to change sort of department norms. And then I feel like you're getting into a situation where it starts to become more practical, or at least easier to sort of change the climate, to change the environment, right? When you're able to change norms based off of having these different groups' needs met in a way that's policy-based and actually enforced, then you can start to really, I think you can start to really create an environment where people can sort of leave baggage at the door, right? So in physics, a lot of physicists will tell you like, oh, you know, physics should be apolitical, right? Blah, blah, blah. But like physics, science, it's all human endeavor. There's so many aspects of our humanity, so many aspects of society that creep in the door. And that includes things like bias. And so if you're changing norms and policies in your department that sort of really can leave bias at the door, then you can have something like, you know, more physics interactions, right? In a way that really allows people to thrive. So I think I'm always going to say that we need to change norms and policies along with bringing more underrepresented groups in so that they can have the climate that they need to be respected and supported, but then also make sure that these people have resources that they need, which are going to be different for students or postdocs or faculty. And I think that in my mind, that's a very clear way to really steer the trajectory of the academy as a whole in the right direction.
Thank you, Charles. Thank you. Yeah, a lot to think about how to enhance the pipeline and then really recruit diverse candidates through all phases of institution. So thank you.
Which also might mean bringing them in clusters. And again, you know, there are lots of resources. There are lots of examples of where these people are. There are other things that get in the way of bringing them in. So we need to sort of attack the problem more head on and bring in a lot of the talented people that are known to exist. Like they definitely exist. We need to bring them in and change the climate and make sure that they have the support and respect and resources that they need.
Oops, sorry, Jack. Do you want to? Your response made me think of one of the questions that was actually submitted in advance. So I think I'll just ask that real quick, and we'll sort of pivot to the Q&A from the attendees. And so someone had submitted a question that reads, what two things would you say to a URM student who is considering but unsure about whether to pursue a postgraduate degree in science and or physics, and why should they do it? I mean, I think it's a really interesting question.
Yeah. Okay. So one thing that I sort of time and time again come across with in my conversations with underrepresented students is concern with paying for STEM grad school. And so what's really important for these students to know is that in almost all cases, a STEM PhD will be funded so that you will have a stipend that will support you paying for living expenses, food and rent. It sort of depends on where you live, whether or not that compensation is enough, right? There are many examples around the country where students are working hard to have higher compensation to address issues with cost of living, for example, in the Bay Area, where cost of living can be very, very high. But underrepresented students need to know that STEM PhDs are funded. That's an important consideration for, I think, many underrepresented students. It certainly was for me as someone who, you know, came from humble beginnings and certainly would be concerned about, say, taking out tens and tens of thousands of dollars in student loans in order to pay for my education. I think another reason to, I think another important reason to consider doing a STEM PhD is that in our society, it being very technologically driven, I would say it is clear that more STEM education leads to more socioeconomic mobility, leads to more opportunities. And again, as someone who has for a long time not only loved physics, but has thought it to be important that I can have a career where I could support myself and in the future support a family. I think, one should really consider that if you have passion to do STEM, get the best and the highest education that you can, because that will really not limit your potential of what sort of work you can do, your earning potential, and the sort of opportunities generally you will have to move around and have different sorts of jobs, maybe doing hands-on science, or maybe doing some leadership work, leading teams of scientists. So I think those are the two things that sort of most quickly come to mind, is that these STEM programs tend to be funded, and that having a large amount of STEM education will give you lots of economic mobility in our society.
I think those are great pieces of advice, and definitely the funding piece is something we try to talk about a lot during recruitment. I think it's an unknown fact, but we try and tell it to the world. And I want to pick up on one other thing that you said. You have this conviction, and it's actually come up a few times, about how you've always sort of known that you wanted to be a physicist. And another question that we received, given the scarcity of role models, can you speak to the moment you became aware that you could become a physicist?
Yeah, that is such an interesting question. So I feel like I can answer that in a number of ways that aren't exactly consistent with each other. So let me try to give a bit of context to what I might say. In a sense, I wanted to be a physicist for my entire life, long before I actually knew what that was. I was fortunate to have in my mother a role model who really loved science, who wasn't a scientist herself, but loved science and loved to talk to me about science. And so that got me interested in science very early. And so I've been sort of thinking about science and dreaming of being a scientist for a long time, even though I didn't have any role models around me that were scientists, nor did I interact with any scientists until I got to undergraduate, until I got to university. Okay, so there's one answer. The other answer is maybe when I was in grad school and I went to the National Society of Black Physicists Conference, and I, for the first time, was in a room full of many kinds of Black scientists, physicists, or physics adjacent people in engineering or chemistry or biological physics, who had very, very wide backgrounds, very wide experiences, some similar to mine, some very different, but who all were in the same room talking about physics, working in different universities or government labs or industry. And so that was a very sort of like self-image reaffirming experience. Like I've had this feeling for a long time, like, yeah, I want to be a physicist. I used to love Albert Einstein. I used to love to read about his work and read about black holes, and sort of it was this sort of abstract thing. And then I see all these physicists. I'm like, wow, okay, this is really a thing now, So those are my answers. Those are my answers.
I think those are great. So this is a completely personal question, but so how did that get into your specific interests in, and I'm not going to try and restate what you said at the beginning about your specific work in graduate school, but about light, which sort of drew my attention. I was really intrigued by that topic and the way that you were describing what it can do with certain materials. But was there a sort of pathway that led you? And I suppose part of the way in which I'm framing this, I could ask the question of like, why did you choose Yale? And like, what brought you here? And how did you get interested in the specifics of the work that you were doing here?
Yeah, so, when I first started college, I was actually an engineering major. And I quickly realized that I needed to change my path, because it was the how things worked that was the thing that sort of drew me the most, that I was most passionate about. Now, with that, I sort of have always been interested in the foundations right? I like to think of myself as an investigator, as a sort of detective in a sense. But instead of solving murders, I'm trying to solve mysteries of the universe. And I happen to do so through experiments. I used to want to do so theoretically. And so that has led to my interest in the foundations of how things work. So when I got to the University of Minnesota, where I got my bachelor's degree, and I took my first quantum physics class, I had a great teacher. His name is Jim Kakalios. He's a condensed matter experimentalist that works on different kinds of devices, but he also cares a lot about SciComm. He wrote a popular science book called The Physics of Superheroes. So that already sort of tells you that he's developed his ability to talk about science in an engaging way. And he taught my quantum class. And after that, I was completely hooked. I felt like I have to be thinking about quantum mechanics and quantum physics for the rest of my life after taking his class. And so I had a research experience with him. So I was fortunate to get in his lab. I had a summer research experience funded by the NSF in their research experience for undergraduate program, where I got to go to UChicago for a summer and do some quantum related research. I did a senior honors thesis where I got to do other kind of materials quantum research. And so when it was time for me to go to grad school, I was completely sold that I was going to do some sort of material physics thing. But in my process of searching for a potential PhD advisor in grad school, I came across Jack Harris, who was my PhD advisor. And I thought his work was incredible. That was incredibly interesting. I think, when you come in as a graduate student, you're really wide-eyed and you think everything is amazing. And it's because everything is, right? Yale faculty and other faculty elsewhere do lots of very interesting science. But I was convinced that the person who became my PhD advisor's work was incredibly interesting. Now, a funny thing here is that I ended up working on something completely different in his group, right? I had this opportunity to switch away from doing material physics stuff to thinking about this, light interacting with matter, thinking about quantum mechanics, thinking about how big a quantum system can be, which really fulfilled my desire to think about foundations of physics, like deep things about why things are the way they are and what they can be. And so that's sort of what set me on the quantum physics trajectory.
I love that combination of sort of breadth and depth, that as you sort of continue going for the fundamentals, you were also sort of trying out all of these different ways in which they could come to bear. That's great. So we've sort of touched on this broadly, but there's a question that's very specific to physics, and it's, what are some of the challenges, in your opinion, that Black underrepresented students and scientists face in navigating the field? So thinking really specifically about physics, are there particular things that you think Black students and scientists are facing?
Yeah, I think one of the biggest things is perceptions of ability. So unfortunately, many aspects of society tend to want to force Black people in particular into a certain box. And that box does not include attributes like smart. And that is a very real thing that you feel immediately when you walk into an environment like Yale, where intelligence is sort of a currency, right? Where that's one of the main ways by which you evaluate a peer or a near peer or someone you either outrank or who outranks you. And so certainly perceived intelligence or perceived incompetence is a difficulty. It also turns out that race and class, socioeconomic status are sort of all wound up in the United States. And it also turns out that that can mean that for some students, some underrepresented students, some Black students, they could come up in an educational system that lacked important resources. And so I think what that means is sometimes, I want to be really careful about how I say this. I think that means that sometimes students can find that they have different preparation than other students. And sometimes they're not in teaching environments where the teaching is sort of cognizant of that fact, right? So sometimes you end up in a classroom where students have different preparation. And it's not always the case that the teaching is geared towards sort of meeting people where they are and building them up. Sometimes teaching can speak to only the students who have had the most resources, that come from the most well-funded school districts, right? That have the wealthy people who can pay the taxes, which then go and fund the schools, that give some students all these extra resources compared to other students. And that leads to differences in preparation when going to next steps. That's an issue. That's a sort of bigger one. That's a society-wide, that's a funding, that's a how do we, that's a tough one, but that's important. And then again, I've already mentioned, but community, right? Again, it's easy to come into a situation where you were the only person, right? For over a decade, I've almost always been the only person like me in the room. And it's really hard to have that identity sometimes, because I can tell you when I was a younger grad student, I was deathly afraid of making a mistake and convincing everyone around me that what people thought about Black people was true. That if I was to fail a test, for example, it would only suggest that it is indeed the case that Black people cannot be physicists, because you don't see them anymore, right? And people already sort of hold these notions sometimes about us. And so Black students or LGBTQ students or students with various disabilities can sometimes carry this weight where they don't see role models. People already don't think that they belong in these spaces. And it's really hard for them to feel like they can actually be human and make mistakes without confirming that they indeed do not belong. And so that is a huge challenge that you're sort of always facing when you're an underrepresented student. I think maybe I'll stop there. I can keep on going, but I should stop.
No, I definitely, I appreciate that. And the ways in which we have this complicated situation in graduate school where there is this sort of, the way in which your intelligence is perceived is not always accurate. And then there's also imposter syndrome on top of that, and how those two things play with one another, and that pressure that so many underrepresented students feel to actually be the best, right? And all of that combined creates this stressful environment so often. It's, I really appreciate you speaking about it so honestly. So I think Ja, I see put a question in the chat, so maybe we'll use that as our final question, which is, what is your next move? Academia, industry, nonprofit? Are you thinking about this? How are you thinking about this? I think this is a question that our students are constantly wondering themselves.
Yeah, so I'm thinking about this a lot, and I've been thinking about it for a long time. Academia all the way. So I'm positive that I want to be a professional physicist. I could do so in academia. I also think that the university system globally is incredibly important. I think it's one of the most important things that humanity has done. And I really want to take a part in being a thought leader in physics and quantum science, but also being part of the leadership of the university system. Again, shepherding it into the future, making sure that the university continues to be like a hotbed for the production of knowledge, right? This is important for just how we understand our place in the universe as humans, but then also for how we, say, produce technology that goes and enriches lives. And I think it's important for us to do so in a way that's equitable, that is not like increasing or driving disparities in different people's experiences, doing so in a way that levels the playing field, that enriches people's lives. And I want to take a part in like making sure the university that I'm at in the future as a faculty member, and that it does that. And I want to sort of take the role as a leadership, as the role of a leader, and sort of be a role model as a faculty member, maybe for other faculty members, regarding what being an effective faculty member looks like, right? I don't believe that is just being excellent at science as a physicist. I think it's being excellent at science, being a good teacher, being a good human that cares about making sure that different people from different backgrounds are in a inclusive space that respects them as people. that really provides them with the resources to thrive. So yeah, I'm going to be a professor, and I'm looking forward to it.
That's a fantastic answer. Thank you so much. And we need you. So we appreciate that path ahead of you.
Thank you.
I want to thank Dean Cooley. I want to thank Charles and Ja for their remarks and this conversation tonight. And also to all the students and alumni who joined us. Thank you for being here. Thanks also to my colleagues, Yasmina Bashirovich-Regan and Kathleen Gallo, for all their hard work in putting this event together along with the GSAA. I hope everyone has enjoyed the conversation and will continue to help us build a stronger community among graduate students, faculty, and alumni. So thank you again, especially Charles, thank you. We hope that you'll all join us for our next event in the Perspective series with Lindsay McMillan Brown, whose name you might have heard earlier today, who's also class of 2019 PhD in chemical engineering, who's working as a research engineer at the NASA Glenn Research Center in Cleveland. And that conversation will take place on December 8th at 8 p.m. More info will be sent out by email. I also encourage anyone who has not already done so to join Cross Campus or to log in if you haven't done so in a little while. Cross Campus, as you may know, is a fantastic way for alumni and students to connect with one another formally or informally. And if there are other ways in which you'd like to be more involved in supporting the graduate school, please don't hesitate to reach out to me and my colleagues. We'd love to hear from you. We look forward to seeing everyone again soon for our next conversation in the Perspective series. Thank you, everyone, and have a good night.
Thank you.
Thank you.